Front of your worksheet here. Hopefully you found really ugly 8, 5, 4, 4, 3, 8, 5 for your petals. What did you notice as a pattern, guys?
The number is odd, and the number is odd, people just say not E, and then when the number is 2E.
Exactly. So the coefficient on your theta, here E, when that's odd, 3, you get 3 petals. 5, you get 5 petals. But if it's even, so if it's 4, you have twice as many petals. Okay? What is this number in front telling us?
For the petals.
Yeah, like how long your petal is, what the maximum it's going to go out. And then what did you notice about sine versus cosine?
It changes what axis is symmetrical to.
Okay, good. And cosine would be symmetric to
The x-axis,
Good.
sine to the y-axis.
Okay. So guys, if you haven't written those down, go ahead and look at that. Jot those down. I want to make sure you've got the right stuff on the front. So if B is even, 2B equals your number of petals. B is odd, you just is the number of petals. A is your petal length. And then cosine and sine your 2, 3, 3 here.
Oh, have you been trying to
It's a polar grid.
Oh, what is just polar? Yeah.
You said cosine of 3. Just 3. What are you talking about? One degree.
It was just on the way you have the formatting.
Okay. The cosine of pi makes more sense than the cosine
Okay, so just gotta multiply it by pi.
All right, guys, let's look at the 2 graphs down below.
No?
These are the 2 equations you should have come up with. The second one is tricky because it is symmetric to both the x and the y-axis. Once we go over how to graph these by hand, I think you'll understand why that one is a cosine graph. Yes.
What do you mean by when theta is equal to pi over 2 in the question?
So if you think about on your polar grid, it's not really the x and y-axis anymore, is it? So if you go vertically, that's pi over 2, right? Yeah, that's all it's talking about there. We're just so used to thinking x and y. Do you guys have questions over the equations? Does that make sense where you pick out the petal length, pick how many petals, looking at that for your B and your A? Yeah, okay. All right, so let's look at actually graphing some of these by hand. All right. So I'm looking at r equals 2 cosine of 3 theta. So what should the maximum length of my petal be? 2. So I'm going to start by setting, instead of r, I'm going to put a 2 in here. So if I was trying to solve this for theta, the first thing I'd do would be divide by 2, and I would get to 1 equals cosine of 3 theta, right? If you want, you can skip this step every time and just start with 1 equals either the sine or cosine. And now we're back to solving an equation that you did a couple units ago. So you're thinking about where does cosine equal 1? So where does that happen once they're under circle? 0, okay. So remember doing this, 3 theta equals 0. We could do plus our 2 pi k because we know we're going around more than once. Divide it by 3. You guys remember this part of the solving? So we'd start with 0, because 0 divided by 3 is still 0. And then technically you're adding 2 pi over 3, right? So for this one, it's not too hard to write them out. You'd have 2 pi over 3. And we'd go again, we'd get 4 pi over 3. Are you guys with me on that? Like you remember how to solve equations? Yes? No, I'm a little nervous right now because some of you are staring at me like, I don't want to say no, but I can't shake my head yes because I don't remember.
So cumulative.
Remember, this gives you, it is so cumulative. Remember, this tells us we're going to have 3 times as many answers as we started with?
Yeah.
Okay, so I got 3 more than I normally would have had. Yes. What if this had been an 8? How many answers would I get?
8.
8 more.
8 times as many, so oh goodness, hopefully it's not 1 that's 4 to begin with. Okay, but remember that's where you got all the multiple answers. That was solving multiple angle equations. Okay, what that does for us when we're graphing our roses, it tells us where the maximum of our petal length is going to occur. So it's going to have one at 0, and we know it's going to be 2 units long. It's going to have one at 2 pi over 3, and it's going to have one at 4 pi over 3. So those are like the ends of your 3 petals. Okay. You can just draw them for right now going through the pole. So you can draw each petal. They're fairly rounded. That is not at all the order that you would graph them if you were doing this over a specific interval, but we are not to that place yet, okay? We're just working on graphing those 3 petals. Another way you can think about it, guys, especially if you get into the ones with a lot of petals, we know the first one should happen at 0, right? Then how many degrees are in a circle?
360.
360. I need to split that up for my 3 petals. So how far do you think it's going to be from one petal to the next?
120 degrees.
120 degrees, okay? So I started at 0, went to 120, 120 plus 120 is 240, use the check, 240 all the way around, another 120. That's another way you can think about it. It's just divide the 360 by how many petals you know there should be, and that's essentially your distance in between your petals. Does that make sense? Okay. I want you guys to try number 2. This one shouldn't be too bad. Notice it is sine, not cosine, though, so it's not going to look exactly like the one we just graphed. So I'll give you a second here. So guys, how many petals should there be?
6.
3.
3.
It doubles if it's an even number.
Yeah, it's double that. Not bad.
That's okay. It is a common mistake, yes.
And the free answer, 160.
Yeah, I wish I could never I don't think many people remember when they were back. First time I ate was yeah, I remember the first thing I tried to eat was like a ramen. Really hard, so we took steaks. I couldn't even, my teeth weren't even going. So I had to take them off and I had to like smush them over my hands and stuff. And then my mom and dad was like, wait, since my kids were really yeah.
Why are you so weak?
Wait, why do we stop? What do you just talk about? So wait, you substitute like stuff like 2 pi over 3 into k.
Some just are simpler, some are just really ugly angles that you're like, oh, well, that's halfway. Yeah, 5 is you get like 2 pi over 5. More pi over 5. Yeah.
That's not the one.
It is not. Alright guys, let's look at number 2. So the first part you're thinking about is 1 equals sine of 3 theta. So where does sine equal 1? Pi over 2, right? And then I divide that all by 3. So your first spot is at pi over 6, right? And again, I don't care. You can do the adding and find the other 2 places, or you can go, okay, I know there should be 120 degrees in between each one. Whatever makes more sense to you. So I'm starting at pi over 6, and I'm going out to... Where is the next tip of the petal going to be? 5 pi over 6, good, or 150 degrees. And then where's your last one? Good. Again.
It's a very big accomplishment for everyone.
No, it is not. I know. I told you I was not drawing them at all in the right order. I was just drawing nice petals. Next time, 5.4 continue will be.
Oh no.
Will be like, okay, I got that much of it. There's more to it. I'll show you.
When's next class going to be on just roses, or is it also going to be on stuff?
We're gonna have some rhyme songs. Yeah.
When you draw you can't go halfway.
That's how. A little weird, yeah. Alright guys, try number 3 for me.
Let's talk about
So guys, let's look at this one. I know you started on it. We're again thinking about when does cosine equal 1, which happens at 0, right? And you can do the plus 2 pi k. This one I'm going to show you the other way. So if I divide by 4, I get theta equals 0, right? That's my starting point. How many petals am I supposed to have on this one? 8. So what am I doing with that 360, do you think? Divide it by 8, so what do you get? 45. So there should be 45 degrees in between each petal. So since this one starts at 0, it's pretty easy. The other way you can think about it is figure out where the 4 are that you're getting when you're doing the dividing and adding, and then recognize the symmetry has to happen. It's going to be halfway in between those, okay? But adding the 45 degrees is just as easy. It's at 45, it's at 90, it's at 135. Yeah. You could, yeah. And again, I am not at all graphing this in order. And guys, if you check this one on your calculator, what did you notice on the ones that had 8 petals? Did you see anything? No, no one saw anything.
Check right here. I don't think so. Probably fairly small. That's really small.
Your petals have gotten a little skinnier.
Probably should lower it.
That's not good.
Heck no. I'm just trying to draw up here in a way that looks okay. This is not easy.
When's the actual next class?
I told you, John. I don't know why you aren't listening.
John just wants to learn now.
Well, he's got to have more patience.
You know the way.
I made mine a little too fast.
John, there's no way you don't understand.
All right. Question on that one, guys. Okay, it's cosine, so we know it's symmetric to the x-axis. Guys, it also looks symmetric to the y-axis. But we know cosine's maximum petal length is going to happen at 0. So I know any of them that end up on this x-axis like this one does, you know you're looking at a cosine graph. Okay? If it was sine with 8 petals, it's off a little. Okay? It's still symmetric to the y-axis and the x-axis, but you don't have this petal going right on, you know, it's not the x-axis, but you know what I'm talking about. The axis in the place where the x-axis, the axis formerly known as the x-axis. Okay? All right? Questions? Oh, I have 10 minutes left for you guys, I think. Let's do, we're going to skip one. Go ahead and jump to number 5, because this has a negative in it.
Oh boy, I like
Yeah, so you can think about it a couple ways. So if I set the maximum petal length equal to 3, when you divide, what do you get this time? -1. Well, where does sine equal -1? Do you mean 3 pi over 2?
Yeah.
Okay. Divided by 2, so you get 3 pi over 4. Again, you could add and find all the other ones, or how many petals are we supposed to have? 4. So what do you expect to be the distance in between all 4? How many degrees in between? 90. So if I know I've got one of them at 3 pi over 4, they all end up at being at the pi over 4. So we're looking at a maximum length of 3 this time. How we doing so far, guys? Getting it? Sort of. Okay. All right, that's hey.
Good job.
That's progress. Okay, guys. So what I want you to do. We've got all of 7 minutes left. So in your packet, can you guys keep turning until you get to where it actually says homework 5.4 at the top? I have a whole bunch. I know. What an exciting day. I got a whole bunch, guys. No, I just ordered one off Amazon. I finally just gave in and bought myself a whole bunch. No one got me one for Christmas, so. I know. I had to buy my own whole bunch. Alright, guys, so now just over the snow days I got. Alright. You are graphing these. No calculator except to check. There's this side, and then this side. So it says homework 5.4 at the top. It's on the back of like a page. Okay. So you've got 6 graphs on that side, and then if you turn it over, you've got 3 where you have to write the equation, and then guys, look at the end here. This is, can you recognize a graph based on the equation? Okay? Which is going to be very good practice for you. And then tell me everything you know about it. Like, if it's a rose, tell me petals, how many, what the length is, symmetric to whatever. If it's a circle, tell me what the radius is, what axis it's centered on, things like that. Okay? Tell me what kind of polynomial. Yes. So now think about what's 360 divided by 5. So you're going 72 degrees in between each petal. I know that's ugly. So it's not going to be exact, but you should be like in between the right 2 grid marks. You know what I mean? All right, we okay?
It's gonna be